Okay, it's my great honor here. So I'd like to spend a little bit time to introduce you about what's happening in the display industry and display the market. So firstly, let me just spend one or two slides to introduce you about our company, Applied Materials. So Applied Materials, we are the world's largest semiconductor and the display equipment manufacturer. And I think our revenue is about 10 billion year annual. And then I think most importantly, we spend about 15%, which is a 1.5 billion spent every year on the R&D. I think this is a huge amount of money, but it is really required in order to fund the innovation that support the technology that is required. And we do have a three segment, semiconductor segment, and the display and adjacent market where I belong to, and also the global service segment. And globally, we have around more than 15,000 employees worldwide, but more importantly, in India, actually, we have almost 3,000 employees, and mainly are the engineers working for the semiconductor, display, and the service on the engineering center here. So I think we do have a good footprint in India already. And talking about the display segment, in the display industry, Applied Materials has served more than 25 years in the industry, and we providing all the equipment that support not only the rigid display that you see today, but also the flexible display that you will see probably in the near futures. And the whole company, we have 50 years of material engineering experience. And just want to show you pictures on the right-hand side. As you can see today, actually we are able to process 3 meter by 3 meter glass substrate in a very fast speed. Actually, we are able to process averagely, let's say, 60 substrate per hour, which means every minute we can process one of this glass. And just a comparison between, we call it generation 10 plus. This is so far the world's largest substrate glass substrate. And compared to a semiconductor, 300 millimeter wafers, as you can see, it's a very, very big compared to a 300 millimeter wafers. And the glass itself is much, much bigger than your a regular king-size bed. So I think that's the challenge and also the contribution from Applied Materials in the display industry. We are enabling this bigger size. And talking about the display, so let me spend one slide to introduce you or define you what is the display. I think human craves information, and I think in the previous session, Bruce from IBM, Donna from Seagate, they both talk about a lot about the data or information. But I think their key point is we are utilizing this data for a lot of purpose, and we storage this data or information. So basically, human crave information for various reasons. Of course, for social networking, for entertainment, for fashion, for the health. So people all need this information. And however, more importantly, all the humans are visual, which means humans actually get those information mostly from our eyes. So if today I want to define what is display, and it also, very importantly, if today, after my brief talk, if one thing I want everybody to remember is this one. Display are really the window to the information universe. I think the previous session has been talked a lot how important is the information, how important is the data that are helping us in not only manufacturing but daily life. But I want to emphasize that display is the windows that for human to access those important information. And then talk about the display era, the new display era. I think in the past, we can say in the last few years, we call it, it is a LCD era. LCD era mainly started from the laptop and then the monitors and the LCD TV. And today, we are kind of in the transition from LCD era, move to the so-called OLED era. A lot of display now starting make from OLED material. And we believe in the near future, the display will even migrate to more advanced display. And one of the area we think could be a natural 3D display. And look at what are the main drivers in each era. In the past, and it actually continued even up to today, most manufacturer driving focus on the scaling. So the glass size I just showed you, the Gen 10.5, Gen 10 Plus, is the latest size. Actually, it started with like a 200 millimeter by 200 millimeter. But all the way, as you can think, the industry or all the makers has been focusing on how to scaling up and why people are pursuing scaling up, mainly to drive the cost down, cost reduction. And this is continue. But at the new era that we are at today, actually not only the scaling up people are pursuing, manufacturers are looking at, but more importantly is the resolution. I think people are demanding higher and better picture qualities. So after resolution, you also see the form factors. So the fashion, and I wanted my screen looks different or wearable, foldable, and then also a better visual performance. And as I said, in the future, we believe the more advanced display era will continue, and probably one of the focus area will be so-called the natural 3D display. Currently, all the display that you have, either iPhone or your iPad or your flat panel display TV at home, I think 99%, almost 100% is just 2D. But we believe in the probably maybe 10 years later, you will see a more natural 3D TV. I'll talk about that in a minute. And in order to support those display era, we can summarize what are the technology roadmap. So the technology also needs to be improved in order to support those the different era. So I think three areas we can say. Number one, of course, the resolution continue going to the higher resolution. And of course, the size is going bigger and bigger. I think all people like a bigger screen. You want a bigger screen TV. So this will also continue. And the third one is the form factor that I also just mentioned. So in order to support these three trends from the market, the technology itself also needs to be improved. So the roadmap we see from the market, from the technology side is, number one, the transistor needs to be improved. I think currently most of the technology is still driven by the traditional amorphous silicon. But we see the trend that the transistor itself moved up to the so-called LTPS. It is the low temperature polysilicon or the metal oxide transistor. And both LTPS and the metal oxide actually give a much higher electron mobilities that compared to amorphous silicon, which enable this, the resolution and the size change. And in terms of the display itself, we also see the trend that from LCD, it moves to the OLED. And the rigid display are migrating to the flexible display, and then the 2D will migrate to 3D. That's the technology roadmap that from our perspective. And I think many of you have iPhone. And then this is how an iPhone display today was built. So these are the display that, iPhone display today actually consists of all these components. I'm not going to explain very detailed, but basically it consists the backlight unit, which gives the light. And then also there's two polarizers. And then there's a TFT backplane, that's the transistor layer. And then liquid crystal and the color filter. Those are the required layers in order to make a LCD panel today. But we do see the trend that actually, for example, when LCD migrate to OLED, So OLED TV, OLED panel, because the OLED material itself is a self-emitting material. So number one, actually, you don't need the backlight anymore. You don't need the backlight anymore. So that's number one. You save that layer. You save that module. At the same time, actually, one polarizer can be also eliminated. And also, you don't need the liquid crystal anymore. It's no more LCD. And also, you can save the color filter because you have a RGB OLED material itself. So you don't need the color filter. So just by changing from LCD to OLED, actually, a lot of material, a lot of components are eliminated. But what does that mean? Actually, that means, so those layers are saved. But the display, the OLED display, when OLED display will substitute, will replace LCD component with a lot of, but with more material engineering process. So this is one kind of mega trend from our perspective that the industry is moving today, that actually the modules, the components that existing today will be replaced by more process itself. But the process itself, of course, is much more difficult than the current process. And that's the area actually requires not only the material company, but also the panel makers and also the equipment makers to collaborate. And I think this is one of the chance for India to address. Because it's not only the manufacturer itself. I think many people talk about Foxconn in the previous two sessions. And I think Foxconn is very good at the manufacturing technology itself. However, the display industry is migrating to the next level that actually require not only the manufacturer itself, but also the material and the equipment supplier to collaborate. So in order to make a good product, you have all three parties to collaborate. I think that's the area that India can address. So we can talk later in the panel. And let me just spend a little bit on the mobile, TV, and what's the future. Each segment I have a few slides. So talk about the mobile first. So again, the mobile, we see the trend that the display will migrate from the rigid to flexible. That's the trend we see. And however, in order to do that, there's a lot of technology challenge. So just one or two examples. So in the center, it shows the standard rigid display structure. So the rigid structure, for example, the cover window, now is actually, it's a very solid, very firm glass, which consists of, it can resist the scratch or damage. But how you make that become flexible? It actually requires new material, right? Because you still want to have that kind of strength, but at the same time, it needs to be flexible. It's not easy. So it requires a different type of material. And same thing on the touch panel sensor. Touch panel is now made by the ITO material. But ITO material is too hard, cannot make it flexible. So in order to make a flexible touch sensor, you have to change material. And once the material is changed, it requires a different process. So again, this is just emphasize again the collaboration between material supplier, manufacturer, and equipment supplier are very critical for the future display. And this is just another view of people are seeing each device at a different distance. So, and that distance actually decide what's the resolution required. For example, normally we look at the smartphone at about 15 inch from your eye. So that defines in order to have a good picture quality, the required resolution is around 800 ppi. But if you look at the top laptop or monitor or TV, because the distance become longer, the viewing distance become longer, actually the resolution requirement become looser. However, but now people talk about the VR or AR stuff. So all this actually you put just in front of your eye. So very, very narrow distance. So which means the resolution requirement become much, much challenge. So you can see today the smartphone normally 500 ppi. Some people can make 800 ppi. But for the VR or AR, actually, we are looking at the 1,000 ppi or even 2,500 ppi. This is actually beyond the current capability. So again, this required the collaboration between all the parties. And also, this drives the demand of OLED, because the OLED actually can move 1,000 times faster than the LCD, because LCD image is driven by the liquid crystal itself. So OLED can move 1,000 times faster, which eliminate or avoid the motion blur, which is very important. So in the mobile display, we see the trend that the industry will definitely move to the high resolution OLED display. That's the trend we see for the mobile device. And talk about TV. I think TV, first of all, this is just the TV evolution. I think starting from about 2005, the industry started to manufacture the LCD TV, and mainly that was replacing the CRT back then. And if you remember, at that time, actually, there's not only LCD, but also another technology called the PDP. The plasma display was also in the market and kind of competing each other. But today, you don't see the PDP anymore in the market, mainly because a lot of investment on LCD, and the cost reduction is much faster in LCDs, which actually enabled the dominate the current market. But now, actually, in addition to the LCD, we do see the OLED TV also in the market. However, today, the OLED TV manufacturing cost is still much higher, so that the penetration rate is still very small compared to LCD. But we do see, the OLED and LCD TV will continue this battle. Different manufacturers try to find different technology, try to compete each other, and we will see this future technology battle continues. And just one slide explaining the current OLED TV, because this is one of the hottest topic in the industry. So the current OLED TV is made by the so-called wide OLED. So wide OLED means actually the material itself, the OLED material itself is only white color, and then only one color. And the RGB is still utilizing the color filter. So this is very similar to LCD, but just replace the backlight with the OLED, white OLED. So some people teasing that this is not real OLED. This is just white OLED. So I think in the future, we believe in order to have a higher brightness and the true OLED TV, the industry technology will migrate from the white OLED to the so-called RGB OLED. But again, the technology challenge, which I'm not going to explain very detailed, but listen here. Actually, the challenge is all the challenge you are having today in the white OLED will continue, and plus more to making the RGB OLED. So again, this require a lot of collaboration. I think only cannot be solved by just one company or one party. It has to be a joint solution from all the parties. Okay, and then just let me talk about what's the future. What's the future of the display? So let's say we talk about 10 years. So let's say more than 10 years. So people are always thinking, what is the future? So of course, it's very hard to say, right? 10 years later, who knows? But one area we see is the 3D. So I think many of you who are in the industry or who know the LCD industry well may challenge me, hey, YT, why you talk about 3D? People already saw 3D TV maybe 5 years ago in the market, but nobody buy. So now you don't see any 3D TV anymore. It is true. I will explain why. However, this is just an example. Actually, Apple, back to 1993, first introduced this Newton message pad. I don't know how many of you have seen this device. It only sells about 300,000 units, and it takes 23 years to last year. Actually, more than 1 billion iPhone was sold. So I think it takes a long time to realize something. So for this 3D TV, what I try to say is probably you won't see next year or next 5 years, but we think in the distant future, we believe, that's our vision, that the display will move to the real 3D TV. So just explain again why the last 3D TV, 3D display did not take off. Mainly because actually the solution was with a glass, and the glass is pretty heavy. I personally tested before. And then also there was no content. And people in general believe that it is more hassle than worth, basically not worthy. And the solution back then was the so-called binocular disparity. So basically they cheating you, that giving you two different pictures to your right eyes and left eyes. This disparity, create this disparity to create this 3D image. But it didn't take off because this is not natural. This is just not natural, so it didn't take off. So with the natural 3D, in terms of technology, we know there are possible three solutions, but let me just, I think you can, there is a holography, and then there's a foveated rendering. I think you can understand, but I think our vision is that the possible solution in the real future is more tends to be the so-called light field display. Let me just explain what is the light field display. So light field display is more like the current pixel, one pixel that from each display, you divided that, become more pixels. So each pixel, let's say you create 25 or 10 more subpixel. So each subpixel can display a different strength of the signal, light signal, and a different color to your eye. So actually human eye can receive much more information from the display. So once you actually receive those information in such density, actually our brain will create a real 3D image, just like our eye seeing all the scene today. Actually, even today, I think we are all human beings seeing all the scenes in 3D. And then that's the same theory, same idea for this light field display. So we kind of believe that the light field display will be possible solution. But of course, saying that is easy, but let me tell you how difficult to make it. So just one example. So in the current 2D TV, if there's only one views, let's say only one views, so the current display resolution for phone is a 400 ppi, for 65-inch TV is a 34 ppi. That's the 2D display that you are seeing today. If we make the 3D light field display, actually how many number of views, this is the subpixel that I was mentioning, we don't know yet. Let's say if just 25 views compared to the 2D, actually the resolution requirement for the phone is 5 times required. And then if the number of scene increased to 100, actually the pixel density needs to be 10 times higher. So that actually almost make the current technology not possible to make such device yet. So you see the red color means so far we cannot make it. Nobody can make it. Still need the technology to be improved. And for the green one is okay. We can make by current technology. And the yellow one is kind of, there are some tricks. We may be able to make it today. So the message again here, the display will continue migrate to the next challenge. But the current solution is not ready, but it requires all the collaboration from the ecosystem. Okay, so again, this is just showing that because I think Dana just also mentioned similarly. So because of the content itself, with a higher resolution, so the new display and the new content, actually it drives a lot more demand of a high performance chips and also more storage, as Dana just mentioned, and also high performance networks. So this is just a table to show a comparison. So if the current 1080p resolution, your content showing 1 hour, it requires about let's say 2 gigabytes, and then we use that as a baseline. If you compare to the 360 replay, I don't know if people know 360 replay, but if you watch NBA, the US basketball, Actually, they do have this technology now introduced that actually they can replay from any angle. Even though the picture is taken from, video is taken from one angle, actually they can replay from any angle by simulation, by a lot of computing. So just by showing that, compare that to the current standard TV, full HD pictures, actually they require the memory, the content size is actually 3,000 times. Of course, nobody will see the 360 replay for 1 hour, but that's just a comparison. So for higher display quality and the new content actually drive a lot more device and the storage requirement. So with that, I'll make my conclusion today, just last 2 slides. Again, for the display itself, again, one thing I want you to remember is that the display is really the window to the information universe. That's number one. And number two, many of the display transition or migration we see today actually require a lot of technology collaboration. And that actually will be the key driving and key focus in the future among the whole industry. Not only manufacturer, but also material and equipment supplier. And lastly, more display technology inflection in the horizon actually will drive a more increase in the silicon content. And look at India itself. I think we can talk more in the panel, but India has a unique window of opportunity. I think Dana also mentioned that the latecomer has the advantage. Actually, you learn a lot from the pioneer. And the industry currently is at the stage that we are transitioning from traditional only scaling up to the next level of technology revolution. So I think this is the great time for India to jump in this industry. So that ends my presentation. Thank you.